ask her, why are you here? Why are you here? You are from Canada. Why are you in South Africa? She will tell us why she's in South Africa, why she is interested in what's in the excavations that's going on in South Africa. You have all the details on the handout. I'm not going to repeat that, but you will see that she has a long history of doing excavations and interest in the origin of humankind. So welcome to this group, and can they interrupt you as you go along, sure, or would you like to handle the questions at the end?
I'm easy either way. If you have a burning question when I'm speaking, then sure, shout it out, or yeah, I'm very informal.
Thank you, and all the best with the lecture.
Thank you. Well, thank you for having me here today. Can everybody hear me? Okay, the mic is sufficient at least. I'm a good projector as well, so it should be all right. Yeah, so today I'm actually here to talk to you about Homo Maledi and the Rising Star Cave. Some of you may have heard about this discovery a few years ago, but I was part of the original expedition, and so I just wanted to tell you a little bit about that and a little bit about the science and some of the research that we've learned since then. So this all started back in 2013 when two sport cavers, people who go underground recreationally, which is not always something everybody wants to do, but two cavers, Rick Hunter and Steve Tucker, stumbled across some bones during a recreational caving trip. They had actually been enlisted by an American paleoanthropologist, Lee Berger, who's been in South Africa for 25 years now and is famous for having found another fossil hominin called Australopithecus sediba. And at the time, Lee was interested in looking more underground than on the surface of the cradle of humankind, where he was used to working. Most of the fossils that we find in South Africa and in the cradle of humankind in particular are either on the surface or in caves like Sterkfontein that are a little bit more accessible. But Lee was interested in sort of pushing those boundaries and getting into the deeper recesses of the caves. Unfortunately, as he likes to joke himself, by that point he'd become physiologically inappropriate for caving, and so he enlisted these two young men to do some of the exploration work for him. The guys actually started in a very well-known cave called Rising Star. It's only about 2 kilometers away from Sterkfontein, and it's been a training ground for recreational cavers for about 30, 40 years now. So it's very well known, but there were still lots of back passages that were not mapped. So the guys actually started in one of the eastern sections and started pushing some of the smaller squeezes. They actually ended up in a very small area off the map, and they ended up in quite a small crawl space. They noticed that this crack went further down, and so they started to push this. They ended up in a small antechamber that then, through another narrow hallway, led into a larger chamber. And in that larger chamber, they actually found something very interesting. This is what they saw. So they saw these scatters of bone, in particular this jaw, this little piece of jaw on the surface of the cave. Now, they looked at this, they noticed that the teeth looked very similar to their own, so there were two choices. One, it was something that Lee Berger was interested in, or two, it was a caver that hadn't made it out. But since there wasn't any gear left, they figured it was probably the former. So they took these photographs to Lee, and Lee took one look at them and recognized them as something really important. Lee has been an explorer in residence for National Geographic for a number of years, so he made a call to National Geographic, to the Science Foundation part of it, and said, look, there's this cave, it looks to have some hominin material in it, I need to mount an expedition and get this material out. So National Geographic said, sure, yes, try not to spend too much money. So then Lee was presented with the problem of how to get these bones out. The cavers, Rick and Steve, had told him that the area that they found the bones in was very difficult to get to. It involved a number of squeezes, there were difficult climbs. Lee himself was probably never going to get into that space, so Lee had to figure out how he was going to get this material out. And he felt also that it was possibly in danger because caves aren't necessarily stable, and so maybe there was rockfall. They know that another caver had been in that space at some point. There was a caver's tell. So he wasn't sure whether this material was safe, and he wanted it out. So he was trying to figure out what to do and how to get this material out. So he did what any good scientific researcher would do. he put an ad on Facebook. So this ad went onto Facebook, and as you can see, it actually describes a fairly unusual set of skills and some unusual features, I guess. So I was doing a PhD in Canada at the time, and my supervisor sent me this ad and said, "Oh, you're a climber. You know, this looks like an interesting opportunity. I don't suppose you also have caving skills." And it looked very mysterious and dangerous, but one of the reasons I was very interested is that I had grown up in Alberta near the Rocky Mountains, and I had spent a lot of time hiking and caving and climbing and doing all sorts of things that I probably shouldn't have been when I was young, but it gave me a whole lot of skills in that regard. Also, as I said, I was doing a PhD in biological anthropology, which encompasses everything from primatology to archaeology to forensics and then paleoanthropology. So I was well versed in anatomy and paleoanthropology, and I had done some of my excavation experience in some fairly unusual places. In northern Alaska, in a place called Barrow, which is about as far north on the North American continent as you can get without falling off the end, and then also in Siberia. So I was very accustomed to, I guess you would say, extreme environments. So I was pretty keen to do this. And I thought I had the right stuff for it. As it turned out, actually, 60 other people also thought they had the right stuff. And so Lee was inundated with these applications for this particular and unusual job. And did I mention we weren't being paid for this? So he interviewed all of us via Skype and said, okay, you know, this is an unusual expedition. It's potentially dangerous. It's deep underground in a cave system. You have to be able to fit through an 18-centimeter slot in the rock. You know, I don't know what to tell your mother if you get stuck in there. And so it really was a pretty unusual set of circumstances. But in the end, 6 of us were chosen. Myself as a Canadian, 4 Americans, and an Australian. So all of us women, all of us in the early stages of careers in anthropology or archaeology. And there's been a lot of talk about why it was all women and whether that was a publicity stunt or whatever. It wasn't really. In part, the lower echelons of anthropology and a lot of students are predominantly female now. That's the case in a lot of disciplines, I think. But it also just happened that all of us had the right skills. In the end, Lee did confess that he had accepted one gentleman to the team, who then confessed a week before he was supposed to land in South Africa that perhaps he couldn't fit through the slot, and so Lee had to change up quickly and find another participant. So the 6 of us ended up in South Africa in November 2013 and had to set up this massive camp. So there were the 6 of us who were tasked with getting the material out, but there was an entire team of volunteer cavers, logistics, cooks, camp managers, senior scientists, anatomists, physiologists, everything you need to put something like this together. And it was a massive undertaking that was done in a very, very short period of time. In about a month, we were from when I heard about the call to when I actually landed in South Africa. And it was a really major undertaking, but I think for all of us, it was something that we felt, you know, was pretty exciting. We'd seen those photos that Rick and Steve had shown Lee, and we all thought, okay, this is going to be kind of a salvage operation. We'll go in, we'll get these remains out, and we'll get out. But the actual getting in was pretty difficult. So this is a schematic of the cave route that we had to take every day. You start at the top right there, at the entrance to the cave, and you work your way down a series of narrow hallways. That's great because at least you're still upright and you're standing on your own 2 feet, but sometimes you have to sort of slide sideways because the hallways narrow down quite tightly. Then you get to a place called the ladder, which is a 3-meter drop where we put a ladder just for safety so that we didn't have to climb it up and down it all the time. And then you get to a place called the Superman crawl. And the Superman crawl is the second photo from the right there. You can just see a pair of boots going into that hole. And it's actually a narrow tunnel. It's only about 45 centimeters high, and it's very, oh, thank you. I love a good pointer. So 45 centimeters.
Someone had black piece. One black piece.
Okay, there, the tape. So about 45 centimeters high, but it's not enough room to get up on your elbows or your hands and knees. So you actually have to slide on your chest, pushing just with your toes. And the reason that they call it the Superman crawl is that for anyone with fairly broad shoulders. You actually have to have one arm above your head and the other arm pinned to one side because there's just not enough room for every part of you. Then it gets a little bit difficult, and that area is called the Dragon's Back. And this is the Dragon's Back here, right on this ridge. And the Dragon's Back is actually a ridge of rock. It's an old dolomite block that fell many, many years ago, but it's about 8 meters high and only about 45, 50 centimeters wide. So you actually literally have to go up the knife ridge. At the time we were, and still we are harnessed in, so there are bolts against the rock wall, but we're wearing climbing harnesses as you climb up that Dragon's Back. But there's an 8-meter drop on one side and a 6-meter drop on the other. So if you happen to slip in that area, you're in for a treat, I guess. Then it gets really difficult. Then we end up at a point called the top of the chute. And the top of the chute is another very narrow crack in the dolostone that you sort of have to slide in feet first, because your next section of the cave is called the chute. And the chute is a 12-meter crack in the dolostone that you have to climb down feet first. Now, at its widest, it's about 45 centimeters, but at its narrowest, it has this 18-centimeter pinch point. So you actually stick your feet down into this 12-meter crack and start working your way down. There's not enough room for you to tip your chin and see where you're going, so you literally just have to feel your way down. So, yeah, not for everyone, I grant, but the very first time I looked down into it, all I could see were these shark's teeth of rocks going down this crack. And at the time, I thought, oh, perhaps I had made a mistake in coming to this expedition, but I think the thrill of actually going down and seeing what was under there absolved me of any fear. But once you actually get through that crack, you drop down into what we called the landing zone, which is that small antechamber that Rick and Steve first entered, and then you pass through a narrow hallway and end up in the actual fossil chamber itself. Now, as you can imagine, the route isn't very easy, and this is the result. I will just point out that these are not my hairy ankles. Thank you very much. But the route is a little bit difficult on the body. We are wearing, obviously, helmets. We're wearing overalls. We're trying to wear protective gear. But even those climbing harnesses have to come off in the chute because there's not enough room for you and the safety equipment. So that is the level of difficulty that you're going through. But I think all of us really felt that it was worth it in the end, because after 3 weeks of expedition, this is a third of the material that we came up with. Okay, so you can see that this is a fantastic array of fossil material. This individual in the center is not an actual individual, it's a chimera, a composite of multiple individuals, because the material was very commingled and fragmented in the cave. And this is really only about a third of what we brought out in that 3-week expedition. And in fact, it is still on display at Maripang, but it leaves on Monday. So if you haven't had a chance to go out to Maripang and see it, this will be your chance to see it here. But yeah, this photo really just gives you a taste of what this material was like. Fantastic, fantastic preservation. And here we have 2 of the skulls that we brought up, and you can see that the preservation is amazing. The teeth almost look like our own. They're very well preserved. They're not preserved in breccia the same way something like Australopithecus sediba or Mrs. Ples is. They're not in hard rock, and they're not fully mineralized. So they're much more like archaeological material. They're very fragile, very soft when they come out of the cave. So the preservation is really exquisite for that kind of context. We also have a really interesting demographic here. So of that, in the end, 1,550 fossils that came out of that first expedition, we had 15 individuals represented, ranging in age from neonates to older adults. And that's really unheard of in paleoanthropology. Paleoanthropology, if you follow it, tends to be kind of a discipline of scraps. People are quite excited when they find a single tooth or one bone. The Leakeys have spent a large part of their life scrabbling through Olduvai Gorge for very, very small amounts of material. And here we were with this just bounty of material, very unusual. And as you can see, we have multiple individuals, and almost every bone in the body represented multiple times. So for us, that was very exciting, because it meant that if we found something unusual, we could check it with the same bone and make sure that it wasn't pathological or diseased, and so we got a really good idea of what the individuals looked like. We also have some fantastically preserved and very uncommon pieces. This is a very complete foot, one of the most complete in the fossil record, and it's one of 5 others that we have in the collection. So again, super unusual and fantastic preservation. We also have this almost complete hand. It's only missing 1 bone in the wrist, and Becca and I, one of the other excavators, actually excavated it, and when we did so, we actually found that the fingertips were curved over the palm of the hand like that. So exquisite, exquisite preservation, and all those tiny little bones would have been lost under most other conditions. So really is fantastic. We also have some incredibly unusual bones. These are 3 tiny ear ossicles. You have very small ear bones in your inner ear, and these are 3 of them representing potentially 2 individuals. And I actually collected these out of the back dirt. All the sediments come out of the excavations, and we sift through them to look for things like this. And I found these 3 in the back dirt the year after we did the expedition. But before these were found, there were only 2 others in the entire fossil record in the world. So we more than doubled that sample size, and that for us is really, really exciting. And if you really need some bedtime reading, I've just published on these ear ossicles, but it's pretty dry stuff. Anyway, all of this material, I just want to emphasize, came out of a single excavation unit, 80 centimeters by 80 centimeters by 20 centimeters deep. Those 1,500 fossil fragments came out of that one excavation unit. So you can imagine the density and concentration of material that was there. And again, that is so unusual in a paleoanthropological context, even in an archaeological context, to get 15 individuals ranging in age from neonates to older adults in basically something the size of a child's sandbox. It's unheard of. So there's all these sort of firsts for this expedition, which was really unusual. But because we have so much material and so many individuals and almost every element represented multiple times, we have a really good idea of what Homo naledi looked like. And we named it Homo naledi because cranially and dentally, so in the skull and the teeth, it looks very much more in our own family than something like an Australopithecus does. So it went into our own genus, Homo, but we gave it a new species name because it's very unusual. And as you can see from both the reconstruction and the sort of chimeric individual, the composite, it is unusual. Homo naledi was very long in their limbs, but quite lean. They had a very small head, about 1/3 the size of a modern human, but in other parts of its body looked very much more archaic, more like other non-human primates. So the shoulders, for example, are very high up and show us that they probably still had some very strong swinging ability. In fact, their shoulders are much more like a gibbon, actually, than anything else. They're very, very unusual. But as you go down the limbs, the hands become more like our own, like modern humans. The wrist bones are almost indistinguishable from our own, but then the fingers are extremely curved. So they were doing something unusual there, potentially still, using the trees or climbing or doing something. They have a very unusual thumb anatomy as well. They have an extremely strong pinch grip. So again, and it's unique to them. We haven't seen that particular configuration in any other hominin to date. So they were doing something unusual with their hands. Whether that was tool use or not, we don't know. We don't have any tools, but there's something really exciting about that anatomy. And it's something that we wouldn't have expected if we hadn't had so much material to work with. So it's been really, really exciting. Interestingly, the actual context of the find was one of the most unusual parts of it. So as I said, it was deep in this chamber inside the Rising Star Cave, but one of the really strange things is that among that huge assemblage of fossil material, we had no other bones of another species. So if you have gone to Sterkfontein or Swartkrans or any of the fossil sites in the cradle, you'll know that there are always multiple species. There's fossils of buck, there's baboons, there's whatever else, Dinofelis if you get further back. So there's always other species because most of the explanations for the material coming into these spaces is usually through something like a death trap, a sinkhole that opens up in these karstic systems. Animals fall in, or maybe they're trying to get water, or they get chased in by a predator. But there's always basically the representation of the species on the landscape in these spaces because it just reflects the natural world around it. But in our example, we didn't have anything. We had 15 Homo naledi individuals and not a scrap of another species. That's really, really uncommon. The other thing we didn't have, no evidence for fire, no evidence for tools, nothing like that to indicate that maybe they were living in this system. So again, quite unusual. We also had no evidence for carnivore or scavenging activity. There are telltale signs that carnivores and scavengers leave on bones when they eat them, and we didn't see any of that. Even porcupines, who gnaw on bones for some of the minerals, leave very telltale marks on the bones, and we had nothing like that. So there was no trauma that we noticed on the bone, no indication that they had, you know, been bludgeoned or anything like that, or fallen into the cave and broken a bone and then died in there, as we do find in other cave systems. So again, very, very unusual for this kind of context. We also know from the geology that there was not one of these sinkholes from above, the way a lot of other sites have been explained. We have a capping chert, which is a layer of rock above the Dinaledi chamber itself that has not been penetrated. There are some cracks a little to one side that do go to the surface and may have introduced some rodent material in the past, but then a flowstone filled that crack around 600,000 years ago. So we know that the cave has basically, and that chamber has been stable since then. So there was just no good explanation for how all this material got in. The material did not get in there by being washed in by a flash flood, something like that. We've had a lot of people try to find reasonable explanations for how all this material got in, but a flash flood is not one of them. We know from the sediments that there is not fluvial movement in the sediments, in the grains of the way the material forms. And we also know that from that beautiful hand that we found, because had there been any movement in the sediments after this hand was deposited, all those beautiful little finger bones would have been lost, and all those tiny wrist bones would have been scattered. So we know that that hand went into that space when it still had soft tissue on it, and we know that it hadn't moved since then because it would have been scattered. So again, very, very difficult to explain this whole set of circumstances. We also know that they didn't all come in some mass catastrophe. They weren't running from a meteorite or aliens, as has been suggested to me a number of times. I get a lot of emails about aliens, and we can discuss them. So we know that they didn't all come rushing in at once. We know that they came in over a period of time. We're not necessarily sure how long that period was, but we know that, for example, that hand, when it came in, there was already skeletonized material there, because we have a femur, a leg bone, sticking up through the sediments right beside it. So that leg bone had to have already been defleshed and in position when that hand came in. So it's some period of time between when the individuals came in, but we don't know how long that might have been. So there's this incredible set of circumstances that is very, very difficult to explain, particularly for paleoanthropology and particularly for these really difficult contexts. And in the end, we actually had to come to the explanation that perhaps Homo naledi was deliberately taking its dead into this space and depositing them. Now that's a very challenging idea for some people, but the difficulty is that we have no other explanation that fits the evidence. And as scientists, we can't just say, oh, well, we don't believe that something with a brain a third the size of a modern human would take their dead into this space. We actually have to find a viable explanation that fits the evidence that we've got. And we are now 5 years later, and we have not found a better explanation for this than that they were bringing the dead in themselves. Now, one of the things I used to get asked a lot, or I would ask people when I spoke to them, is I'd say, okay, we have this really unusual context. What would convince you that this deliberate disposal hypothesis is valid? I mean, what else would convince you? And they would say, oh, well, maybe if you found another location with the same kind of situation. Well, okay, we did. So, this is the Dinaledi chamber here, and it was called the Dinaledi chamber in part because the whole system was called Rising Star, and Dinaledi now, it means star in one of the local languages. And so it's down here, and in this area up here, we found another deposit of Homo naledi material. This is now called the Lacetti chamber, and it is almost as difficult to get to as the Dinaledi chamber, but it's a little bit shorter. But in order to get there from the main entrance, you have to go this way and not this way, and there's no connection between the Dinaledi chamber and the Lacetti chambers. And in this second area, if you can imagine, it's even more difficult to excavate than the original one. In the Dinaledi chamber, with the 6 excavators that we had, we actually could only work in 2s and 3s because the space is quite small, and we're always on our hands and knees because there's actually a large chunk of dolomite right above where we work. In the Lacetti chamber, it's just me because it's literally in a blind tunnel, and I work with dolomite on either side of my shoulders, and I'm kind of Tyrannosaurus rexing it through the sediments. But that is how I excavate most of the time. Looks pretty comfortable. But yeah, the blind tunnel is here, and so it's a very, very difficult place to work. It's a little easier to get to, but not as fun to work in. But we have now found 3 more Homo naledi individuals in this second chamber. One of which is this absolutely stunning, in my mind at least, adult male, who we nicknamed Neo, which means gift. And as you can see, he's remarkably complete, and we have a very, very complete skull. We have all 32 teeth, and we have most of his skull, just missing that right-hand side a little bit. But what was really exciting about Neo is that for us, he kind of presented a Rosetta Stone for us anatomically. In the Dinaledi chamber, those 15 individuals were very commingled and broken up, and so even though we kind of made that composite skeleton, we weren't really sure what pieces went with what individual, and so we weren't positive about things like body proportions and things like that. But with Neo, we have a very good idea because he's on his own, and he is, as you can see, quite complete, and I think he's quite beautiful. But that's, you know, maybe for bone geeks like me. But one of the things that we got asked very, very quickly is, okay, this is all very interesting, the anatomy is very strange, how old is Homo naledi? And so we spent a lot of time on this problem. In 2013 and in 2015, when we actually published the scientific material, we didn't come out with a date, in part because we wanted to describe all of the fossil material first before we started doing any destructive testing. In most archaeological or paleoanthropological contexts, people don't date the primary fossil material because it's too precious. So they date faunal material that they find in the same layers, or they date flowstones that are nearby, something like that. We didn't have any faunal material to work with. We did use the flowstones, but in the end, what we wanted to do was make sure that we had described and researched all the fossil material and then took it to the next step and did the destructive testing. So in the end, we used 6 different methods, 2 of which are directly on the fossil material themselves, on the teeth. Electron spin resonance is one of the best ways to do that. And we did double-blind lab testing for each so that we could be as sure as possible about what date we got. Because the date we got was pretty surprising. So I don't know how many of you can absorb how incredible this date is. So this material looks very strange in terms of the anatomy. It looks very primitive, but this date is very, very recent for the way it looked. And in particular, the anatomy had suggested to a number of other researchers when we published it that Homo naledi would have to be 1 million more years old because of the primitive nature of its anatomy. But we know from lots of other species that that isn't necessarily so. We have lots of examples in the rest of the biological kingdom that say that a taxon's origin can be very old, but populations can survive into the modern day relatively unchanged anatomically, and that's crocodiles, coelacanths, all kinds of species look very similar to their ancestors millennia ago and seem to survive no problem. So to me, it didn't seem all that unusual that we could have a hominin example like that. Now, what's really exciting is that Homo naledi is not the only one that's like that. If you do follow paleoanthropology, Homo floresiensis is a small-bodied hominin that was found in Indonesia in 2005. And originally it was dated to 17,000 years ago, but it has been redated recently to 100 to 60,000. But again, very, very modern age for how primitive its morphology looked. So there's something kind of funny going on there. But there's yet another example. Just 2 weeks ago, some scientists named a new species of hominin from the Philippines called Homo luzonensis. It's a mouthful, but there it is. There are only 12 pieces of this particular hominin, so its actual taxonomic grouping and where it fits into the greater family tree isn't quite certain yet. But what is certain is that it's another small-bodied hominin on an island situation that lived relatively recently. So in the same way that Dinelletti and Lacetti kind of demonstrate that if you just have one example, it's a phenomenon. If you start getting another one, it becomes a pattern. Now we have 3 hominin species that look very unusual, that look very primitive, but that lived into a modern period. So for us, or at least for me, that's super exciting because it is challenging us to start rethinking about how we configure that family tree. And we don't actually know where Homo naledi fits into the human family tree just yet. We've tried to get DNA, we have not succeeded as yet, but that doesn't mean we won't still keep trying. But Homo naledi, you know, doesn't fit neatly into the Homo family tree yet. And in fact, I try not to use that tree analogy at all because I think it confuses a lot of what we're talking about now. In fact, I think it's probably more like a braided stream or a glacial flow in that you have these tracks that come and go. Some of them go into each other. We were just talking earlier about Neanderthal DNA, and we know that there is Neanderthal DNA in modern humans. As I said before to someone else, I'm in the 99th percentile for Neanderthal DNA, and I'm very proud of that. But it just reflects that anatomically modern humans and other hominins on the landscape at the time were interacting. So it's pretty exciting. And in fact, at the age that Homo naledi is, it's entirely possible that it interacted with anatomically modern humans. We know from northern Africa that anatomically modern humans were around at about 350,000 years ago. Is it possible that they were on the southern African landscape as well, and that maybe they did interact with Homo naledi? Now, we don't really know what that interaction looked like, whether it was positive, negative, or neutral, but it's an interesting question to talk about, you know, what those interactions might have looked like and whether, you know, whether they in fact connected with each other. Now, one of the other things that's really interesting about this is that in South Africa, it's also possible that Homo naledi either was or partly was the maker of some of the stone tools that we find. In South Africa, we don't have a lot of good contexts where we find skeletal remains with tools. So we don't know who's making the tools. And in fact, that same fact applies to Eastern Africa, where they already know that there were multiple species on the landscape at the same time, and that someone was making stone tools, but nobody has, you know, the hand clutching the hand axe yet. So, you know, we don't know who those makers were, and perhaps it was both. We don't know. But it's a really intriguing question for Southern Africa because it means that all of those Stone Age technologies that we find in places, it's possible that they were made by Homo naledi. And then that leads to the question of, was this technology or was this culture being passed from group to group, or did it evolve independently? How did that work? And again, some of those questions we may never get at, but it's something really interesting to talk about. Now, for me, this find also reinforces that we have so much more to learn about humanity's history, and that there's a lot more going on in human evolution and adaptation than we really assumed at the beginning. That very, for me, irritating picture of the nice linear line from some non-human primate through, you know, through Australopithecus, through Homo erectus, all the way up to almost inevitably a white male, is just not an appropriate way to think about it, and that the family tree is a lot bushier and a lot more interesting as a result for that. So I think it's actually hugely exciting, and for me it's an awesome time to be in my profession because we're having to kind of scrap a lot of the old ideas and start fresh, and that's an awesome position to be in. But also for me it emphasizes that exploration isn't dead either. I was one of those kids that loved reading all the Arctic and Antarctic exploration journals and the, you know, Burton through Africa and all of these books, and I thought it was wildly exciting, but I also thought that the age of exploration was dead. And for me, that's not true. Now we know Homo naledi was discovered in a cave that is very well known, practically in our own backyards, and people had been in there for decades and had not seen this. So for me, it reinforces that you need to keep looking, but also keep looking in places that you know are familiar, but with fresh eyes, because you never know what you might find. And I think that, again, is very exciting to the new generation of scientists that are coming in, regardless of what discipline you're in, is that you don't have to go, oh God, it's all been done, what am I going to do with my life? There are things to find, and there is a lot of exploration that still needs to be done. And then finally for me, in the end, whether it's East Africa or Southern Africa, this find reinforces, as do so many, that the origins of humanity are in Africa. And that for me is really important, and I think it's immensely exciting that also this research is being kept in South Africa. Foreign researchers like myself have to come here to do the work. They have to contribute to this economy, this scientific community, and come here, as opposed to the old model where people would come, grab their little treasures and ferret them off to some other place. I think it's really important that the material and the work is being done here, and that we are trying very, very hard to bring up young South African students to get involved in these projects and to start taking an interest in their own history and their own past. And it's very gratifying for me also that this, I mean, in many ways does speak to our common past. This is about not just South African heritage, it's world heritage. It's what is, you know, common to all of us. And I think at a time when it seems the world is getting more divisive, this is something that really speaks to our common heritage and our commonality. And I think for me that's a really good message to pass on to young South Africans and then young people generally, is that this is something that unites us all rather than divides us. And so for me that's pretty important. And I also think finally that it's a really great way, it's a great story, but it's a great way for just your average citizen to engage in this science. We went to a lot of trouble to make all the research open access, so anyone can download the articles, download in fact the 3D shape files of the fossils. We've scanned them and put them on a website called Morphosource. So if you're interested, you can download the shape files and print them out as a 3D print yourself and see for yourself what they look like. And for me, again, that's super important because this is something that is important to all of us as a global community, and I think you should have access to that. Science for me has never been something that's up in the ivory tower and that shouldn't be accessible to everyone, especially something as important as this, which is about all of us. So if you're interested, please join me in that exciting journey, and I think there'll be lots more to tell in the near future. Thank you. I'm very happy to answer questions if you have them. No. Sorry.
Yeah, okay. Yeah?
Is it possible to tell how old the Homo naledi individuals were when they died? Were they all old people, or were they different ages,
No.
or don't you know?
Yeah, it is possible, and we do that primarily by the teeth. So we have some very, very young individuals, some neonates who, you know, somewhere around the time of birth. And we get that from the dental material and obviously the size of the bones, whether they have sutures in their skull or epiphyses in their long bones. So we have a couple of very young individuals. We have 4 or 5 sort of young-ish individuals, juveniles, somewhere in the range of like 8 to 14, 15, we think. This all, of course, assumes that Homo naledi grew on the same trajectory that modern humans do, but we kind of do an educated guess in terms of whether they followed a non-human ape pattern or a human pattern, kind of find a middle ground. But so yeah, so we have some juveniles, and then we have some very old adults whose teeth are very, very worn down, so we can't say how old exactly they are, but we can say that they are adult and that they have been around for a good long time. Enough that they've worn their teeth down significantly. Yeah?
Yeah. Homo naledi, is it a different species like Denisovan, or is it not? Where does it fit into the line up there to where we are?
Yeah, excellent. So yes, absolutely a different species. If Homo naledi got on the bus with you, you would get off. It's not, you would recognize them very clearly as not us. But in our own larger family, so in the Homo genus, but its own species. Denisovans are another excellent example. So they haven't even been given a species name yet because we only have a finger bone and a couple of other fragments, and they're only known from DNA. And in fact, there are a number of other species now that we are seeing from DNA but don't have any skeletal material from at all. These are now called ghost genes, because we know they come from somewhere, but we don't know what the species is. So yes, very clearly a different species to us, and a different species to most of the other things that we've found in the cradle beforehand. So Australopithecus africanus, Australopithecus sediba, Paranthropus, all of those species, we have a reasonable idea of anatomy on, but Homo naledi just takes the cake in terms of the volume of material, so we have a really good idea of what they look like, and I think we're pretty confident about the new species level designation.
So what happened to them? Like the Neanderthals, did they just die out? Did they assimilate with the modern humans, or what happened?
We don't know, and we don't even know about Neanderthals. We know that they interbred with anatomically modern humans, but we don't know why they're not still on the landscape with us. We don't know if we did something that contributed to their demise, or if there was some environmental factor that contributed to their demise, or what it was that actually made them go extinct. And I mean, that's the case with a lot of species in the past. We don't necessarily know. Yeah. People could do that.
Do you think that the axis was larger originally? Something fall in or so, because it seems very difficult for people to have gone through that small crack.
Yes, and I mean, I do joke that, I grumble about taking my backpack, never mind my dead grandmother. So it's, to conceptualize them bringing their dead into this space is difficult to get your head around. But here's the difficulty. If there had been, and it's possible that the cave has changed in terms of the geology in the last 300,000 years, but 300,000 years isn't a lot of time geologically, and we know that basically from the Dragon's Back, that one area that I described to you, to the chamber has not changed in 300,000 years, and the geologists tell us that both from the sediments outside and the geology inside. And the real kicker for me is that if there had been another entrance at any point in the last 300,000 years, another animal would have gotten in there. We find, I regularly have to compete with porcupines going through the Superman crawl, and we have lots of other species. We have baboons on the landscape. We find all of these species in other parts of the greater cave system where the access is easier, and we find baboons, if they've wandered in and they get lost in the labyrinth, they end up dying down there. That's fine, but we don't find any of that in the Dinaledi chamber. So it's very, very difficult to explain, if there had been another entrance of any form, why another species didn't end up in there.
If your hypothesis about the burial site is correct, were these bodies placed, or were they just dropped through that final chimney?
Yeah.
And was there any sign of ritual?
Excellent question. So that is the theories that we went back into the Rising Star chamber to test. So when we first started thinking about this, we have this chute, that 12-meter crack in the dolostone, and then there's that landing zone, that slightly smaller chamber. And we initially weren't finding much material in there, but again, we weren't excavating in there because we were concentrating on where we had actually seen material on the surface, in the Dinaledi chamber. So 2 years ago, we went back in and started excavating at the base of that chute, that drop zone area, on the theory that if material was simply being tipped into the top of the chute and sort of making its way down the chute, that would explain how it gets disarticulated. So the bodies start decomposing in the chute, and maybe they just go plinkety, plinkety, plink, plop. And so some of them disarticulate sooner than others, so that would explain it. It would also explain why some material is articulated and some material isn't. It would also explain why we don't see any trauma to the bones, because it's not falling from a height, it's just simply working its way down that crack slowly. So we started excavating in that area, and in fact there's quite a steep sediment slope where we come down from the chute. You land onto kind of a flowstone, and then there's a steep slope of dirt, and then it leads into this hallway that goes to the Dinaledi chamber. So we started at the top of the slope thinking, okay, if the material was plopping down the chute, we might not find anything at the top, because obviously you'd think everything would end up at the bottom if the sediments have been moving that whole time. So we started at the top thinking, oh, maybe we won't find much, and yet we found quite a lot. So that material actually will be published probably in the next year or so, but we found another 2, possibly 3 individuals. Some of the material articulated, some of the material looks like it went in there still fleshed, and that for us presents problem, because how does that material start at the top of the sediment slope and not at the bottom? And if all of it was coming down the chute, it couldn't get from that antechamber through the hallway to the Dinaledi chamber without piling up on the wall between. So in going after that question, we actually gave ourselves more problems than we thought we were going to. But it's exciting work. It's exciting problems to have, because now we have to explain, okay, how do you get a deposit of 3 individuals articulated at one end of a choke point and individuals on the other end of this choke point, and not much in between. So the plot thickens.
No sign of conscious placement.
Yeah, sorry, I meant to, no sign of conscious placement. So in that one excavation unit in Dinaledi, as I said, the material is very commingled. So the bones are quite fractured, and then they're mixed together, the individuals. So, you know what, that's one of the reasons I try not to use the word burial, because people get the idea that it's sort of nice, neat rows of individuals, and it's not. They're very mixed, very commingled, and that takes some explaining as well. How do we get that context? In other cultures, even in modern humans, there are many ways that the dead are treated. Everything from, you know, eating your ancestors to placing them in mausolea or you know, pyramids, and everything in between. And there's a particular treatment called excavation, which is practiced by some indigenous people, both in North America and in Europe, where the bodies are laid out on piers and just left to the scavengers to disarticulate, to rot, and then either on the next seasonal round or the next time someone is there, they pick up what's left, they bundle that, and they bury that. So, you know, there are many different approaches to the treatment of the dead that I think we have to consider as part of this. And it doesn't reflect any different behavior. All humans have the same intellectual abilities, and yet they're practicing treatment of the dead in a very wide range of ways as well. So, yeah, for me, it's pretty interesting.
Yeah, please, Dr. Elliot, thanks. I just want to make one comment, and then I'm going to ask you 2 questions. Forgive my English. I hardly ever speak
Yes,
English.
I apologize that I was not able to give this lecture in Africa.
I just want to add to this, to my colleague here, that the Neanderthals, according to latest proof, eventually they died out due to inbreeding.
That is one suggestion.
Yeah,
Yeah.
Dr. Svante Pebo from Germany is confirming that.
Yep.
Okay, my 2 questions is regarding the species. Is Dr. John Hawkes, whom you worked with,
Yes.
absolutely convinced that this is a new species? And in the same vein, this Lucenensis, is that also a different species in view of the lack of any long bones and any skulls? Is it possible?
Yeah. Well, okay, so to the first question, is John Hawkes convinced it's a new species? It's not up to John Hawkes, first of all. We have a now 150-person research team, so it's a collective decision, and when we actually did the descriptions and analysis of the material in 2014, which I was part of, that was 45 researchers working 10 to 12-hour days for 6 weeks on that material. So it was essentially like crowdsourcing the science, and that was everything from senior scientists to new researchers. So it was very much a consensus decision that it had to be a new species. And I'm utterly convinced that it's a new species, in part because we have so much material. And every time someone says, oh yes, but that anatomy looks a bit like this, we can say yes, but this other part doesn't. And that mosaic of features, if you took just a single feature, and this is the problem with most paleoanthropology, and the problem with Luzonensis, if you just took a single tooth, you could say, oh, well, it's clearly Homo naledi. Well, except that then when you get a foot bone and it doesn't match, then that's a problem. And a lot of anthropology and a lot of species have been named on very, very small amounts of material. I'm holding judgment on Homo luzonensis at the moment, in part because there's so little material. I don't think they can actually say that with any great confidence yet. Maybe they'll find more material and that will give them greater confidence. It's another reason things like Denisovans haven't been given an actual species name, even though genetically they are very obviously distinct, but they haven't been given a species name because we don't have any anatomy to look at. So But yeah, I think the species designation for Homo naledi is pretty clear. Luzonensis, not so much. And in fact, paleoanthropologists are dedicated arguers for things that they can't prove. But a lot of species, even now, things like Homo habilis, there are still people who argue that it's a garbage can species. It's not really a thing. It's just what people call stuff they can't figure out what else to call it. And so there's still a lot of debate in anthropology about how you designate species, what features are important. Classically, we use the skull and the teeth to do that, but I think we're learning, especially from things like Homo naledi, that that's maybe not a always reasonable approach. You can't tell what the lower body is going to do just from the cranial dental material.
So, Dries? Following up on this question, maybe you can just clarify for us what constitutes a species. Because as we will often discuss this issue that Neanderthal and modern humans interbred to produce offspring that we presume was fertile. So that is now two species that are interbreeding with each other. And then if we say it's based on anatomical features and that two species can be separate even if they're very close genetically, what is then, where does race fit into this whole picture? Because races are also, I've got different, slightly different anatomical features like skin colors or maybe shape of the skull, or shape, maybe not shape of the skull, but some anatomical features that are sort of a bit different. And that's how we can identify different races. So where do we draw the line? What is how does it?
Yep, and I mean that is a debate that rages among zoologists, biologists, you name it. No one has ever been able to settle on a definition of a species. So in mammalian evolution, and if you're dealing with sexual animals, where you have males and females, then you can say, okay, one of the definitions is that a species is a species if it doesn't interbreed with another species to create viable offspring. That does not work as soon as you get out of basically mammals, and even in mammals it doesn't work that well. So all of these ideas were sort of formulated, and then we've had to kind of backtrack on them every time we find new evidence that suggests that that's not true. So it's a real problem. I mean, the classic definition is the one you described, is groups of organisms that interbreed and produce viable offspring. Well, that's great, except that it doesn't work in 90% of the rest of the biological world. So it's a problem if you're talking about plants. It's a problem if what do you do with yeast? They just bud. Okay, so, but we have different species, lots of different species, bacteria. So every time you sort of enter into a new realm, you have to readjust. And even the species concept in terms of sort of location or niche occupation, which is another explanation that they have sort of used, it's basically called the niche theory, is that a species is separate if it occupies a unique niche and doesn't overlap with another one that then it might come in contact with. But now, especially when you get big migrations, you get animals moving, or even humans moving across the landscape, inevitably connecting with other species, it falls down very quickly. So as far as race goes, we know without doubt that all humans on this planet today are one species, and that's in part getting back to this problematic description of interbreeding and producing viable offspring. But the difficulty with the race concept is that it, again, is not real once you actually start interrogating it. So we like to think that we can identify races quite easily, but you can't do that skeletally, you can't do that consistently from a scientific point of view. And the way they kind of frame it now is that obviously there are population differences, there are genetic features that predispose certain groups to have certain kinds of features, but those features are not unique to that group, and there never have been and never will be pure races, because this planet has always been a palimpsest of people moving in and interbreeding and mixing with each other. So the race concept is very difficult because it gets promoted and continued to be used in things like forensics when they want to identify who this person is. But it doesn't actually work from a biological or a scientific standpoint. If I pulled all your skin off right today, which I promise I won't do, and brought 5 scientists in here to determine your race, they would not be able to do it. They might be able to make an educated guess simply by the location or the demographics of an area, but they're really pretty bad at it.
Marius, I'll go along and then I'll start again with Simon. Marius?
Thank you for your lecture, very interesting. Could you determine a time scale, time lapse, from first to last to most recent deposit? Or was it a once-off incident? And can you give us a description of the excavation area itself? Was that the sandbox size, or was it, say, another whatever a square meter each?
Sure. So let's start with the excavation first, because then it sort of leads nicely into the other. So the excavation, when we first went into the Maledi chamber, there were about, I don't know, 200-300 very small fragments scattered on the surface of the chamber in maybe a 4 to 5 square meter area. So the first thing we had to do was pick up all those tiny little pieces, and that included that fragment of jaw that you saw in the photograph. So that was just lying on the surface. So we did basically a sweep of the floor, not literally sweeping, but we picked up every piece of bone that we could find. And that amounted to about, 250 fragments. And I mean, a lot of those are, sort of fingernail size pieces. They're not big. Something like the jaw was quite nice to have, and it was just on the surface. Once we did that, there was actually just a rim of what looked like the edge of a skull, just peeking out from the sediments below the surface. So that's where we concentrated our excavations. So we opened, in archaeology you call it a unit. So basically, sometimes we work now in 50 centimeter by 50 centimeter squares. At that time in 2013, we opened up a slightly larger one, which made it 80 by 80. And so then we start working our way down. And we didn't just, somewhere in Afrikaans, just somewhere go wherever we wanted to, because we wanted to concentrate on that one area. Since then, we have opened a couple of test pits on either side of that excavation unit, but again, only 50 by 50 centimeters. So we got down 20 centimeters in that sandbox-sized unit and then ran out of bone. So we weren't going to keep excavating if we weren't getting bone. And I actually did what's called a test sondage, so sort of dug further down below where our bones stopped, another 45 centimeters. And so we're now 65 centimeters into the sediments, and the bones are only in the first 20 centimeters. So that's kind of strange.
What period was that deposit?
Yeah, and we don't know.
Or just a once-off?
Yeah, we don't know. We know that it wasn't a once-off because we know that they came in over a period of time, but what that period of time was, we don't know, like whether it was tens of years or hundreds of years. One thing that is really interesting about Homo naledi, though, is that those 15 individuals, and in fact, the individuals from the Lacetti chamber as well, their anatomy is so similar, you would almost think they were clones. And I hate to use that word, but the teeth are almost, an individual compared to another individual are almost identical. So a very, very small family group or something, but a generationally, don't know for sure.
Any response from religious creationists or fundamentalists to your work?
Yeah, I mean, periodically, I do. You know what? I'm very much of the mind that if someone is willing to engage with me respectfully, I'm willing to engage with them respectfully. Unfortunately, a lot of the time that isn't necessarily the case. But you know what? I've presented these talks in Dallas, Texas, which is kind of the heart of the American conservative heartland. And I thought, geez, how's this going to go over? But you know what? They were fascinated. And just like you, asked the right questions, asked cool questions. I mean, I think it's very difficult because the only real difficulty, I think, comes in you are going to be a biblical literalist. And I think if you take that position, you're just being willfully ignorant. And I use that in the nicest way. But because it doesn't, even if you're going to be a biblical literalist, I think I'm talking to skeptics, is that even the Bible doesn't match, right? I mean, where did Cain and Abel's wives come from? Like, you only get in 2 pages and there's already inconsistencies. So, but for me, it's irrelevant. The biblical stories, and Christian or otherwise, even if you're talking about the Bhagavad Gita, the Quran, whatever religious texts you want to talk about, in my mind are not in conflict with science or with evolution, as long as you are not adhering slavishly to a story that doesn't fit to begin with. So when I talk to Christians or otherwise, I don't have any problem engaging with that. I've had someone ask me, oh, so is Australopithecus afarensis, Lucy, the one that's sort of famous from East Africa, was she before or after Adam and Eve? And I thought, okay, I mean, fair question if that's how you have been raised. And I don't believe in stupid questions, because you don't know what you don't know until you know it. So I said, well, actually, excellent question, because it depends on how you define Adam and Eve. Are Adam and Eve when we get to be anatomically modern humans, in which case it's before Adam and Eve. If you count Adam and Eve as the second we got up bipedal and became something in a hominin line, separate enough from other non-human primates, then maybe it's on the cusp. But yeah, I mean, I try to engage respectfully if they're willing to engage respectfully, and that's my general attitude.
Thank you very much. It's lovely to listen to you. You're so fluent. Thank you. I have 3 questions. The one is a personal one.
Okay.
How much of the dating could you do in South Africa? Are there any facilities?
I've never been asked so much about dating. We did do some of the dating here. We did some of the geological dating on the flowstones here at Wits. Yep. The rest of the dating had to go elsewhere, unfortunately. And the other difficulty is that because we were wanting to be so sure about it and doing these double-blind labs, we had to send stuff elsewhere. So some of it went to Europe. We've tried Svante's lab several times for DNA, and we've sent stuff. So some of the stuff also went to Australia, some of the stuff went to Europe, some of the stuff went to North America. But yeah, we had to be as sure as we could about the dating. So, and it's unfortunate there's not a lot of that technology that is here, but it is growing. So I think gets back to that point about making sure that the science gets done here. So if we're doing the science here, we're going to start demanding that the peripheral science also gets done here. So, you know, I think just by encouraging people to work here, then the other disciplines will start following up and making sure that we have the infrastructure in place to do it. But I mean, fair enough, paleoanthropology isn't on the top of a lot of people's lists for things that need to happen in an emerging economy, you know.
That's my first question. My second question is, I find it interesting and not really feasible that with such a difficult passage for these, can I call them people for a moment, to take their dead through.
It's difficult for all of us, don't get me wrong. I struggled with it.
Exactly.
Yep.
It means that they had to be really determined to get them from here to there. For me, that's a bit of an indication of we have to do this specific thing with our dead. You'll comment on that, and then my last question. Well, do that one.
Okay, we'll do that one. Absolutely. It's literally sat around that first 3 weeks every night after we came up and excavated, and we're like, what is going on here? The senior scientists on the surface, who would never get down in there and could only watch us on TV monitors, Lee took me aside at one point and said, are you guys cherry picking down there? What are you doing? Because all we were bringing up was hominin material. He's like, where are all the other species? Like, what's going on? Why aren't you guys finding something else? So, you know, every night when we finished, the whole group of us would sit around the fire and try and figure out how you could get what we see. How do we get that? You know, how do you get 15 individuals in a child sandbox, no other species, all of this kind of stuff? And we just kept coming up against these terrible walls. It's like, well, we don't have evidence for this. We don't have evidence for that. Yes, the route is difficult, but if you look at modern human analogies, we go to a tremendous amount of effort for our dead. We build mausolea. We build the pyramids. We, you know, go to extreme lengths. We enslave other populations in order to build things for our dead. So I think, you know, there is something very powerful about death. And, you know, when we talk about kind of the spectrum of behavior, we know that animals recognize death. They obviously recognize death because they eat each other, and they know that that they have killed something, so they can eat it. But even within a species or within a population, they recognize they're dead. They don't, you know, mother chimpanzees will carry their dead infants around for a little while and then finally drop them. We have evidence. The elephant graveyard thing is not very consistent and not ubiquitous, so it doesn't really count as a ritualized behavior. But we know that there are behaviors that start encroaching on some sort of recognition and treatment of the dead, and consciousness. And I get a lot of people who say, oh, well, you know, but this thing with a brain the size of an orange couldn't possibly have been making these incredible decisions about taking, you know, its dead into this space. We know we have known for many, many years within our own species and within the entire biological kingdom that brain size has very little to do with cognitive ability. We've known that for a while, and yet we cling to that thing because we're the big brains on the planet, and we like to think that way. It's a very egotistical way to think, but, you know, we're very egotistical for that reason, and so we're like, yeah, of course, whatever we've got is where it's at, and we're at the top. Well, we're pretty quickly not going to be at the top if we go the rate we're going now, but yeah, you know what, I think we don't know what a species like that was capable of. And I think that the why they took their dead in there, what motivated them, we will never know. We won't ever be able to speak to them, but there it is.
Johan, how died Jan? Misschien niet.
Was the one quick?
No,
okay.
let's wait. Otherwise, there's a number of other people that.
Yeah.
Keep your question, Johan.
Just out of interest, on a typical working day, the time to get in, time to get out, what would that be about?
Yep, so the very first time that I went in, it took about 45 minutes to go the 200 meters from the surface to the actual chamber. So you can imagine how slow going that is. Now I can do it in about 20 minutes without unencumbered. So, but if we're carrying gear or carrying fossils, yeah, it usually takes half an hour, 45 minutes. We just recently brought out, in that area that I was describing where we found articulated material at the top of that sediment area in the landing zone, we actually ended up plaster jacketing a large amount of very fragile material, kind of the way they do with dinosaurs. So we plastered this whole lump of stuff and then undermined it and packed it up. And we tried to pack it into the smallest possible size we could because we have this limitation of getting up and down the chute and past that 18 centimeter pinch point. But the blob, as we like to call it, ended up being 24 kilograms. And so myself and 5 of my cavers, it took us 2.5 hours to get that out of the cave, the 200 meters. Yes, slow going.
Okay.
Could you identify any collagen in the bones?
Any collagen?
Yes.
No collagen yet. And part of that, I think, is just the context that it's in. The sediments are very wet, so there's not a lot of running water down there, but we're very close to the water table. And the geologists have told us, and we know that as the water table rises and falls, those sediments have become inundated with water. So the sediments are quite moist. The cave itself stays at about 99% humidity. It's around 18 degrees Celsius, so it's a little wee bit sticky down there. So the sediments are quite moist, and as a result, collagen and DNA leach very quickly. And with them being even as old as they are, relatively modern, all of that has been lost. It's part of the reason I do most of my other excavation work in places like Siberia and Alaska, because cold climates are good for preservation. Tropical climates are really terrible for bone preservation.
Okay, Dion?
Is there a conflicting or different theory than yours about burial site from a scientific point of view? Is there a completely opposite theory?
Yeah, when we first published the scientific descriptions and then the context and suggested that our best guess for how they got in there was deliberate disposal, we got a lot of armchair anthropologists, professionals, who said, oh, well, that's not possible. Something with a brain the size of an orange, something that didn't have fire, couldn't possibly do this. But none of them to date have published on it. So there is no alternate theory that has been actually tested and presented in a formal way. Because we've had people say, oh, well, no, there had to have been another entrance. Okay, so where are all the other species? If there was another entrance, there would be other species. Something. Every other site in the cradle of humankind and every other site, in fact, in the entire world, has a mixture of species. You'll always get a buck or a porcupine or a baboon or something also wandering in. Or if there's a predator, there's no predator on the planet that predates a single species to the exclusion of every other species. It's really difficult to explain. And in the last, in the 5 years since the original discovery, no one has come forward with a viable alternative to our explanation. And we keep finding evidence that at least supports more of what we are saying. It gets more complicated. And you know what, quite frankly, if someone, a year from now, if we get evidence or someone else comes up with a theory that fits our explanation better, that's fantastic. That's science. To me, it's not the phenomenon that changes, it's the explanation of the phenomenon. And if we find new evidence that better explains that phenomenon, I'm not wrong, I've learned something. That's important. So.
Okay, Johan? Well, no?
Marina, how is it possible that all those dead in there were without any damage done to the bone by scavengers up in the landscape? In other words, what I'm saying is, as of today, we die, and we know we die of disease or car accidents or what.
Yep.
But what you were saying is that all those people had undamaged bones. They were not attacked by any animals.
They were not attacked by any animals. No.
That's funny.
So here's the problem. So the bones are very fragmented, so sometimes it's a bit hard to tell. But we don't have any carnivore or scavenging damage on the bones. We do have some minor pathologies. So we have an osteosarcoma, a small tumor on one of the bones, but not sufficient to have killed that individual. We have some dental caries, some cavities, things like that. But in general, their teeth are remarkably healthy. Well, because they're not drinking Coke, right? So they're, but their teeth are very, very healthy. We have some minor, what they call walking fractures in the toes. So from walking long distances, there are some fine hairline fractures in the feet. Again, not sufficient to kill the individuals. So we do not have any evidence on the skeletons of how or why they died. The difficulty is that, for example, an epidemic or some sort of disease that kills people very quickly and shows no remnant on the bone, we would never know, right? So you only see diseases in skeletal collections that affect the skeleton, because that's all we're left with. So it could have been the case that, with the infants, they could have been stillborn, they could have died in infancy. Infant mortality has been a huge problem throughout human history for no particular reason that would show up in the skeleton. So those infants could have simply died or starved or do whatever. They didn't starve for long, because we would see that in the bone as well, because you see stress markers in the teeth, or you see changes in the bones if people are starving for a long time. The adults, we don't know. We don't have anything that indicates that they were diseased or that they were killed violently. or by animals. But, you know, bad things happen all the time. And on a landscape like that, it's inevitable that, you know, someone could have fallen somewhere on the landscape, and the family went, ooh, well, now he's dead, but now he gets bundled up and put in this special place. But yeah, I don't know. There's a lot of speculative stuff, but yeah, I tend to stick with the evidence, and we don't have a lot of evidence for any of that, unfortunately. We may find out later.
Okay, Dieter, and then Jan.
You were referring to cognitive ability and brain size.
Mm-hmm.
Would you comment on a notion that Neanderthals had bigger brains than us sapiens, but we have better cognitive abilities? Does that had something to do with their extinction?
I think it's pretty clear now that yes, Neanderthals had a bigger brain, but that they were equally cognitively capable. You know, there's still a lot of debate about whether they did or whether they didn't deliberately bury their dead. So we're already, I mean, at that stage. And Neanderthals aren't that far off, don't forget, in the time frame from Homo naledi. Neanderthals, you know, are 350,000 years to 40,000 years. So they were on the planet at the same time as Homo naledi. They just weren't in Africa. So bigger brain, probably the similar cognitive abilities. Homo naledi, we have some evidence that although they had a very tiny brain, their brains were actually structured in a very similar way to our own, in that the shape of the actual brain suggests a more complicated cognitive ability than non-human primates. We're getting a little bit of that just from the inside of the brain case. So there's convolutions and impressions of the brain on the brain case. But again, highly speculative. But I think it's pretty clear that Neanderthals probably made some of the tools that are in Europe, probably, potentially buried their dead, may have had culture in some of the ways that we think about that, you know, artistic abilities or stuff like that. But what's funny for me is that every time we find another species like Neanderthals or like Homo naledi that starts to encroach on what we think is human, modern human, then we try to move the goalposts instead of learn from it. So like, oh no, if that's what they do too, then this other thing has to be what makes us human. And one of the cool things for me is this raises a lot of really interesting questions about what makes us us. You know, why are we special? Why are we now the only hominin around when there were clearly plenty around? I mean, when you look at the East African example, and even in South Africa here, it's probably a case of Darwin's finches. There was probably an adaptive radiation of hominins, and that there were multiple species like there are buck today in the South African landscape, and that they all just occupy small niches, but they, you know, perfectly capable of existing on a landscape together. But as far as cognitive ability, yeah, hard to say. They were, I mean, Neanderthals were bigger generally than modern humans, so, you know, it's not unheard of for them, I think, to just, or not, I think they probably had very similar cognitive abilities to us. And how they died out and why, there's lots of accidental circumstances that can just wipe you out somewhere along.
Jan, wil jy nou?
Maybe Johannes already asked the question, jy wil nie 'n bietjie opstoot daar, dan kan jy hoor as 'n bietjie oud, nee. Maar
sy's 'n bietjie siek.
It's quite clear from the start from what I've read before. The long bones are broken, quite a few of them shattered. Now, normally, if we bury our deceased, we don't break their bones. There are some exceptions in some cultures, but we don't do that. So, if they didn't fall down, why are those bones broken like that? I'm talking about the long bones. And could you see from the fracture of those bones how they got broken?
Yep. Excellent question. So we know from most of the bones that the breakages were post-mortem, so after they had been defleshed. And we know that by the way they break and how, like, so when you break a bone and you're living, it makes a certain pattern. If you break it when it's dry, it makes a very specific, very distinctive pattern. So most of the bones that are in the Homo naledi and Dinaledi deposit were broken long after the individuals died. That's pretty clear. Why they are so broken, one explanation has been just the pressure of the sediments on top of them. That doesn't really explain why we get some that are nicely intact and some that are broken. Now, as you said, there are lots of cultures. A lot of cultures don't break bones. A lot of cultures do. Even into modern times, a lot of cultures do. So it is possible. In the area that I worked in Siberia, we were working on a Holocene burial area, and these are nomadic pastoralists who would go on a seasonal round. And so this is about 5,000 years ago, but they had animals, they had horses and things like that, but they would go on a seasonal round as the weather changed. If someone died out in the winter rounds or whatever, they would just leave the bodies there. They would pile some rocks on top of them if they could find the rocks. But we're talking about Siberia here. There's not a lot of, rocks and trees to work with. So they would pile what they could, and then on the next seasonal round, they would pick up whatever they could find of who was left. And that literally meant, in some cases, they would mix individuals who had both died out on the far reaches, and they would mix them together, and then they would bundle them into usually a seal skin. Siberia has a freshwater seal that lives in Lake Baikal. They would bundle them into these seal skins, bring them back to the home base, and then rebury them there. So when we were doing the excavations, the seal skins had all long disintegrated, but we would find, someone's head, but clearly someone else's leg. Some of it would have been broken. And again, we get back to this problem of, if they left it out, surely there would be scavenging or predator marks on it. We don't have that. How do you explain that? How do you explain 15 individuals in that small space with a lot of breakage? So, I joke, and I will never say this in front of the press, but it's like sort of the world's first serial killer. Maybe he was putting them through a wood chipper and then into a gunny sack, because it's that kind of breakage. But it's not breakage while the flesh was still on and while the individual was still alive. So there's all these problems still, which for me is great, because it means I hopefully will still have a job. But yeah, there's all these questions that we try to get at, but we may never know. So.
Okay, last question, again.
Just wanted to ask, there's no proof that there's any changes in that over the years. There was any, the cave itself that were bigger and then became smaller.
Nope. As I said, from that Dragon's Back area to the fossil chamber, geologically has been very stable in the last 350,000 years. Obviously, this is a crustic system. Like all of the cradle, it's a sort of Swiss cheese of caves and caverns underneath the surface. But we know that one section has not changed much in 300,000 years. Obviously, the cave is moving all the time. We do still have rock fall. Usually not when we're there. But the cave has changed, but we know that one segment has not changed in 300,000 years, and that even if it had, again, we're back to this problem of, if there had been a better, easier, more accessible entrance, something else would have gotten in there.
So they were basically small people as well, because they had to.
They were tiny. Yeah,
they were tiny, so you could.
I didn't actually mention that. So from the reconstructions that we've done, we're looking at sort of 1.3, 1.4 meters high, and in the range of 45 to 50 kilos. So slightly built, very, very slightly built. Yes.
Okay, Ahata, she will be the last one.
Okay, I just want to mention to you that Marina did bring some books along. They go at a dang of a bargain at 200 Rand each. There's still 2 of them left in the front. If you're interested, just speak to me. I'll hand you the book after you've handed me the cash.
So it's not a book specifically on Homo naledi. It's actually Lee Berger and I wrote a book, Handbook to the Cradle of Humankind. So it's sort of a general interest book about the area, and a little bit about the existing flora and fauna, and then quite a lot about the hominins and the species that had lived in that area in the past, and hopefully it's interesting.
Just a quick last question. Yeah. The excavation, only a third has been done, so the other you're carrying on with the.
Oh, I've got lots of work to do. Yeah.
So that's
that one unit is probably only a tenth of the actual floor space that we have in that one chamber, and that's not even talking about Lacetti and some of the other areas. So yeah, as long as I can still fit into the cave, I'll be grinding away.
Interesting things to find still.
Still interesting things to find, yeah. Watch this space. I'll have to come back and give you another talk when we have a new update.
Thank you.